Hi, welcome back to your new lesson. This is Lakshmikant Tiwari. In this lesson, I'm going to teach you about a spaCy library or a Python package which we will be using for our natural language processing. So spaCy is basically used for a feature extraction from a text data, and then we can apply machine learning models for a classifications or a sentiment analysis. All right. So basically in this lesson we will be doing a linguistic feature extraction, but let me show you an example how and why why we need a linguistic feature extraction. For example, in example 1, if I say Apple is looking at buying UK startup for $1 billion. All right, so the Apple is looking at buying UK startup for $1 billion. And the example 2 is issue at the Apple, as we had seen in our previous video in tutorial number 3. Alright, now you see the difference here. In the example 1, Apple is organization here, and it is here a proper noun and organization name. But you see here at this Apple, this is the noun here. And one more thing I should tell you that. So by using this spaCy library or a Python package, we can do linguistic feature extraction from a text data. There are a lot of the things which this spaCy library can do. This is a free open source library for advanced natural language processing in a Python, and which we will be using for a tokenization for our text or document data. The tokenization means segmenting text into words, punctuation marks, etc. For example, if we tokenize example number 2, it will be tokenized into 4 tokens, issue 8 the Apple. So these are the 4 tokens. Alright, and in the Apple is looking at buying UK startups for $1 billion. In this, Apple is looking at buying U.K. Okay, so this will be a same token. It will not make U and the K a different token. Alright, so this is how tokenization is done in spaCy, and then we will be studying about the part of speech tagging. I mean, which one is noun, which is a pronoun, what is the verb, and all those things. After that, we will be studying about dependency parsing, like which word is depending on which another word, like here at, looking, Apple is looking at, buying. Alright, so Apple is looking at buying. All right, so these are the kind of the dependency. And then we will be doing the lemmatization. What is the lemmatization? Assigning the base form of the words. For example, let's say was, is. Okay, so was, is, and am, where, all those things is a form of verb be. So this lemmatization will compress the information, and it will minimize the total number of words in your documents. And lemma, like let's say you have rats, and the rat, it will be compressed into just a single rat. And then we will be using sentence boundary detection, like let's say here we have just a single sentence, but if we put here a dot, then by default it will divide this Apple is looking, that will be one sentence, and then add buying UK startups for $1 billion, that will be the another sentence. So that is the sentence boundary detection in a paragraph structure. And then we have a named entity recognition, like you see here. In this case, Apple is looking at buying UK startup at $1 billion. Here Apple is organization, but here issue at the Apple is a fruit. All right. So this is how this entity recognition is done in spaCy. I'll show you how you can do that. And then entity linking. This is kind of the disambiguating textual entities to unique identifiers in a knowledge base. Knowledge base means the vectors which is already hashed into a spaCy library. And then similarity analysis, like comparing two words. For example, dog and the cats are kind of the similar word because they represent a same category of animal, household animal. But if we put dog, cat, and the banana, then the banana and the cat, neither banana and the cat nor dog and the banana have a similar type of characteristics. And then here we have a text classification, assigning categories or labels to whole documents or parts of a document. And then finally we have rule-based matching, finding sequences of token based on their text and linguistic annotation similar to the regular expressions. And then finally we have a training and then serialization. So these are the things which actually can be done with the spaCy. spaCy don't give you out of box the chatbot or any the algorithm, direct algorithm, I mean direct end result, but the spaCy is a kind of the group of the algorithm which you can use for your research purpose, and then finally you can utilize all the modules of the spaCy, and then finally you can build your end application using a spaCy for your natural language processing. Alright, so let's go ahead. You can get the spaCy model from this link. You can just open this link. Let's go ahead and open this link. So there are three types of model available in spaCy. There are multiple languages like English language and German, French, Spanish, Portuguese, Italian, Dutch, Greek, etc. So these are the languages available for spaCy. And then there are three types of the library available. One is very small, which is just 11 MB size. If you don't have a fast internet or you are working with mobile data internet, then you should download just this small library package. Otherwise, if you have a Wi-Fi or a fast internet, you can also download this medium size library for English. Otherwise, you can also download this large one, which is almost 800 MB. Okay, or you can say the 1 GB of the data you need to download. So these are the models which is available in spaCy. But in this lesson, we will be just downloading the SM so that it should work for everyone. Okay. You can install a spaCy by writing this command pip install spaCy in your Jupyter notebook itself. And if you want to use it into your Anaconda or command prompt, just write pip install spaCy. Let's go ahead and run this. I should get something result like the requirement is already done. And then for the same for these two other commands, the requirement is already done because I have already installed these libraries. So you can go ahead and install these libraries, and the link for this Jupyter notebook will be available in a video description which you can download from a GitHub. Alright, so why we use actually a spaCy? Let us make it a little bit more clear. Processing this raw data text is really very difficult, and most words are very rare, and it's common for words that look completely different to mean almost the same thing. And it is also very common that the word which looks similar but they mean a completely different thing. So this goes in both ways. The same words in a different order can mean something completely different. Even splitting text into useful word-like units can be difficult in many languages. So in a natural language processing, it is not always guaranteed that the tokenization or splitting of the words or sentences will be done exactly, I mean, with 100% accuracy. As you see here in the model, it has also says that the accuracy is not 100%, but it is somewhere belongs 80 to 90%. All right. That's you see here what happens. While it is possible to solve some problems starting from only the raw character, so it's usually better to use linguistic knowledge to add useful information. That means if you are good in English and linguistic, the form of the English or grammar, part of speech, etc., you can add your own model while classifying the text. Alright, so I'll show you in the next lesson how you can add your own the custom rule. In fact, I'll show you in this lesson as well using a pipeline how you can add a custom rule. So that is exactly what spaCy is designed to do. If spaCy doesn't have a rule, you can also add a custom rule. All right. So let's go ahead and see how spaCy works. spaCy takes a text data. Then the very first stage of NLP is a tokenizer, and then there is a tagger like part of speech tagging, and then there is a parsing, and then named entity recognition, And then finally, if you have some, the custom algorithm which you can put here, and then finally a document classification is done in NLP. So in this lesson, we will be doing tokenization, tagging, parsing, and named entity recognition. All right, so let's go ahead and start with the tokenization. What is a tokenization? Tokenization is a task of splitting a text into a meaningful segments called tokens, and the input to the tokenizer is Unicode text and the output is a doc object. For example, if I tokenize this string, so it's kind of a text, but the output will be a doc object which will have a 4 token. Issue ate the apple. So these are the 4 token. All right, so this is the tokenization. During process, spaCy first tokenize the text. That means segments it into the words. It first look to the spaces, and then it looks to the special characters like exclamation marks, dot, the period and comma, etc. Okay, so let's go ahead and first import a spaCy, and then we can load our the small library in Jupyter Notebook. So first I'm gonna import spaCy. Let's go ahead, add few more the code cell into a Jupyter Notebook. All right, so here we have NLP is equal to spaCy dot load, and then here inside this we have en underscore core underscore web underscore sm. All right, so this is how we are going to load a small form of dictionary, or you can say a spaCy model. It is already actually a trained model. spaCy have a trained model, which is which you can say a knowledge base where a lot of the text information is already stored, and you can get those information here. You see, it has a vocabulary, syntax, entities, vectors, and written text, blog, news, comments, etc. Its size is just a 91 MB, and in the pipeline it has tagger, parser, and named entity recognizer. And there are 20,000 unique vectors are present in this small, it is medium library. Actually, here is a small. In a small library, vectors are not present. All right. Perfect. So let's go ahead. Let's go ahead and create a first doc there. Doc is equal to NLP. Here I'm gonna write here. Apple is looking at wine UK startup for $1 billion. All right. So now you see, this is our sentence which we are going to split into a token. And for splitting it into a token, we can just call, in fact, as I told you earlier that the spaCy takes input in the form of the raw text, and then finally it provides a final object in the form of doc object. All right, which we can actually iterate over. So here we have a for token in doc. So let's go ahead and get the token there. Print token dot text. Print token dot text. So you see here we have got all the token. Apple is looking at buying UK startup for. You see here u.k and dot is being put into a single token. Okay, in single token, so it is not splitted. And then for and dollar is splitted in another token, and the one is another, and the billion is in another. All right, so here what we would like to do here, we can also put $1 in a single, that in a single token. That is where spaCy provides you a freedom to add your own rule. That we will do later in this, not in this lesson, but later in this video series we will be also writing our own rules to extract the features from the text. Because this lesson is just getting familiar with the spaCy library, so let's go ahead and get familiar with this library. All right, Now what I'm going to do here, since here you see how it works by looking infix, prefix and postfix. If I put here apple is in the, okay, so here this is a infix. Let's say then what happens, here I need to put, okay, so you see here, let's say how it will divide this document. Now you see it has divided these documents into two parts. Each is another one, okay, so it has each and then nt. All right, so this is how smart this spaCy is. It automatically identifies that how to put the token and how to put the stop words while tokenizing a document. All right, so this is very small introduction of tokenization. Let's go ahead and start with the tagger. The tagger, in which I'll start first with part of speech tagging. All right, so let's go ahead and start with the part of speech tagging. Part of speech tagging, which is very widely also known as a POS. All right, so we have here a part of speech tagging. Let's go ahead and first understand how it works. After this tokenization, spaCy can parse and tag a given documents. Do remember that there is always a need of the tokenization. With this, you can see here the tokenization should be always done before any tagging, etc. And once tokenization is done, then you can perhaps change the parsing and the tagging, the sequence of these. Okay. Now let's go ahead and see this. The three linguistic annotations are available as a token attribute like many NLP libraries. spaCy encodes all strings to hash values to reduce the memory usage, which actually improves the efficiency. Because it has a lot of the words, it is knowledge base is very high. So spaCy has hashed all the words in a dictionary, and spaCy basically works with those hashing numbers, but at the final representation or final interaction with the user or a programmer, we need to put their underscore after a name of any attribute. I'll show you how. Let's say you have a document, Apple isn't looking at buying UK startup for $1 billion. Let's go ahead and get first the text here. This is a text, and then we are going to do here a lemmatization. All right, so in the lemmatization, I'll show you how it will work there. For example, let's say if I write here for the token in doc, and then I can write here a print finally token dot text. All right, and then we have a token dot lemma. You see here a lemma is lemma. I told you that is kind of the lemmatization, which limits the usage of the words. I mean, which compress your word dictionary, and which is really very important because there are so many words, millions or billions of words, different kind of the words, and it's part of the word, which is actually very necessary to compress the which is why it is very necessary to compress the dictionary. All right, by using a lemmatization. Now with this, you see apple is apple, but each has been lemmatized into a B form of verb, and this NT within fix it is a form of the not, and looking is lemmatized into a look, and at is at. Buying should have been lemmatized to a buy, but it is at buy. UK is UK, startup is startup, for, and all those things are almost the same. And to test this more, what we can do, I'm going to also see here a part of speech and the dependency along with the stop words as well. But before that, one more thing I should tell you here that Alright, so do you remember in my previous video NLP tutorial 2 in which I have shown you how you can print a formatted text into a Jupyter notebook like something this. Earlier it was like this, but after formatting using f-string it is like this, like a tabular form. So here you see it is kind of very wiggly jiggly. So what I'm going to show here, I'm going to first format this text so that you can see it very properly using a f-string. So let's go ahead and copy this and I'm going to paste it here. Then I'm going to use here f-string. The f-string can be used with something like this. Let me delete it first. So it's f-string information, and there the whatever you want to print, you need to put it into a curly braces like a dictionary, and then with a space and then curly braces, then space and curly braces. So I'm gonna just print here two columns. The first column is token.text and then token.lemma. So let's go ahead and print this token.text, and after this what we need to do here, after this we will be needing here the space which we want to put. I mean it's kind of the padding after token.text. So I'm going to put here a 15 character padding, and after that here we have another one which is token.lemma. Alright, and then it asks how much we want to put the padding. That I'm gonna put here again 15. Alright, let's go ahead and print this. Now you can see here very clearly these two columns. So apple is apple, but each is a form of b, and ent is a form of not. Looking, the base form of looking is look, and at is at, of course, that is in base form. Okay. Alright, so let's go ahead and now print a part of speech. For this sentence, if we print parts of speech, we need to call here token.pos, that is the part of speech underscore, which can be shown into a string form, human readable. And then we have here, we are going to put 10 character space after part of speech. Now you see here we have got a part of speech as well. And in this part of speech, you see this says that the proper noun, auxiliary verb, and this is kind of the particle. Let me show you a full list of this part of speech. So you can visit spaCy.io API annotation, and there let's go ahead and see in the part of speech tagging, there are universal part of speech tags and the English tags. Let's go ahead and see this universal part of speech tag, and in that you can match there, let's say this verb ADP. What is this ADP? ADP is adverb position, okay, add position like, in, to, during, okay, and then ADV is adverb, AUX is auxiliary verb, and CONJ, that is the conjunction. Alright, with this you see here we have SYM, that is the SYM. Let's go ahead and see what is the SYM. SYM is a symbol like a special character, like a dollar, percentage, copyright, plus, minus, etc. So those are the character. Otherwise there would be a space, and NT like infixes word or like a particle. Okay, so this is how we can extract a feature from a text data using a spaCy. All right, after this part of speech, what I'm going to do here, I'm also going to show you a stop word. If any word is a stop word, then it will show, okay, this is a stop word. What are the stop words? Stop words are most widely words which is actually like is, the, and, articles, etc. So these are the most widely words which actually doesn't convey much information while classifying or getting a information from a text. So while doing a text classification or analysis of text, we need to also look that we also need to take care of a stop words. Let's go ahead and first see how many words are stop words there. that we can get with the token dot is underscore stop. So this says that is stop word. Okay, if it is a stop word, then it will say there true or false. So apple is not a stop word, is a stop word, and this infix is not is a stop word, and at is a stop word. You see here for is a stop word. So these are the stop word which actually doesn't convey much information in text classification. But you see here a dollar symbol is not a stop word, because this dollar is really very important in this context. For example, if I say Apple isn't looking, okay, if I don't tell you at, okay, it doesn't list the information. Like if I say Apple isn't looking buying UK startup for $1 billion. Okay, I haven't said at, but you have got the information from this sentence. But if I say Apple is not looking at buying UK startup for, and let's say if I miss this dollar, then I'll say just 1 billion. Then there is, I mean, it's really very ambiguous. What is the amount? Okay, it's a dollar or a euro or whatever currency is. So this is how SpaCy is working. It identifies the importance of the word and it put that whether it is a stop word or non-stop word. And non-stop words convey the much information in a text classification. Alright, now let's go ahead and see a dependency parsing. A dependency parsing means how a one word is dependent on another word. So in fact, calling a word, we can say a token. So these are a token, how one token is dependent to the another token. And to do that, let me first write a heading, dependency. This is kind of the syntactic dependency of a sentence. So here we have a dependency parsing, and in the dependency, syntactic dependency parsing, you can see here the labels of these dependency, which we will be matching after the analysis of our sentence. So let's go ahead and first understand what is the dependency parsing. SpaCy features a SpaCy features a fast and the accurate syntactic dependency parser and has a very rich API for navigating the tree. The parser also powers the sentence boundary detection and lets you iterate over base noun phrases or chunks. So we are going to use here this time a chunks instead of the token. So let's go ahead and iterate our chunks, okay, the noun phrases. So here we have a for chunk in doc dot noun chunks. Okay, so inside this noun chunks, what we are going to print here, we are going to print root text and its dependency. Alright, so let's go ahead and print it into a formatted string, which we can do with f string. And since we are going to print here a three column, the first one is text, that is chunk dot text, original text, and then I am going to put here a 15 character space. Then I have chunk dot root dot text. What is the root of that text? Then I'm gonna again put here a 15 character space, and then finally I'm gonna call here chunk dot root dot dependency. What is the dependency for particular word? Okay, so let's go ahead for particular token. So let's go ahead and run this. If we run this, we see here what are the noun in this. So it has a noun apple, and which is nominal subjects, which shows that dependency. And then here it has a p object. Let's go ahead and see what is the mean of that. And p object, we can get it here. It's not there, so we can get it in English. Yes, so it has an object of a preposition. Alright, so it has an object of preposition. So we have buying UK, the startup. I think let's go ahead and make it a little more space there with the 30 perhaps. Yes, so apple has a apple root, buying UK startup is a startup. As I have already told you that spaCy is not 100% accurate. So its accuracy is somewhere in between 80 to 90%, which is okay. And sometimes it doesn't actually classify very accurately. That is where your rule-based classification works. So later in the videos, I'll tell you that how you can actually write your own rule, and then finally you can add in the pipeline of this spaCy to classify the text. Because you see here, it is kind of not pretty much clear here. Instead of buying UK, it should have been just a UK or a UK startup, okay, for a noun. Alright, so let's go ahead and see a named entity recognition. Why named entity recognition? As I told you earlier that if I say here Apple is looking at buying UK startup for $1 billion, and the example 2 is issue 8 the Apple. In this you see the Apple, in the first example Apple is organization, but in second example Apple is fruit. Alright, so that is why we need a named entity recognition. Alright, so let's go ahead work with the named entity recognition. The default model identifies a variety of named and the numeric entities, including the companies like Apple, Google, Microsoft, and locations like India, New York, Britain, England, United Kingdom or USA, organizations and the products. So you can add arbitrary classes to entity recognition system and update the model with the new examples. Why? Because let's say you have your own organization like a KGP Talkie, or you have your own organization. So in that case, you need to actually make sure that the library, spaCy library, the pipeline is updated with your own the custom rule. Alright, so that it can identify KGP Talkie as a organization instead of just a normal text. Alright, so let's go ahead and see here a doc. In a doc we have Apple isn't looking at buying UK startup for $1 billion. Let's go ahead and see what are the named like the location and organization, etc. products. So for that, what we can do, for int in doc in ints, that's entities, and then it is gonna print here int dot text, and then here we have int label. Alright, so we have here a label. Alright, so it says that Apple is organization, a UK, this is GPE means geographical location, and $1 billion is money. Alright, so this is how you can do a named entity recognition. So for your the classification, text classification, this named entity recognition is really very important. And in meantime, if I show you again this pipeline sequence, we have covered tokenization, tagging, parsing, and named entity recognition. Now I am going to tell you how you can do a sentence segmentation. Alright, so this will be the second last topic which we are going to cover today. But before that, let's go ahead and add few more the cell here. Alright, so here I'm gonna write sentence segmentation. Alright, so in the sentence segmentation, you see what happens. A document object sentences are available via doc.sends. Okay, that means you can access by calling doc.sends. Alright, so this is usually more accurate than a rule-based approach. spaCy already have actually a set of the knowledge base. It has a trained on a lot of the data, articles, essays, news, Wikipedia. So it has kind of already inbuilt sentence segmentation rules, but that is not 100% guaranteed that it will work in all the situation. So sometimes you might need to write your custom rule strategy. or a custom strategy. All right, so let's go ahead and see here a doc. A doc is again, Apple isn't looking at buying UK startup for $1 billion. There, what I'm going to do here, I'm going to see here in the form of the sentence for sent in doc.sends and then print sent. So with this it says that this is a complete one sentence, so there is no other sentence in this document. Now let's go ahead and create another document like a doc is equal to doc1 is equal to NLP, and in this I'm going to say you welcome to KGP Talkie, and then I'm going to put here a period, and then I'm going to say you thanks for watching. All right, then I'm going to say here please like and subscribe. So here we have our a new document which should be the NLP instead of just LP. All right, so we have our doc1. Then what I'm going to do, I am going to send iterate it over a for loop. So for sent in doc1 dot sends, and then I'm gonna call here print sent. So in this now you can see we have a 3 sentence: welcome to KGP Talkie, thanks for watching, and please like and subscribe. All right, perfect. Now let's go ahead and I'll show you another document. Let's go ahead and copy this, paste it here. Let's make some changes. Okay, let's go ahead and delete this. So what I'm going to do here, as you see by default segmentation is being done at dot, that is the comma, period, comma, exclamation mark and the question mark. For example, if I say like this, if I run this, you should get 2 sentences, and if I put here exclamation mark, you should get 2 sentences. All right, but if I do not put let's say if I put some underscore, then let's say what would you get with the underscore? What it did with this KGP Talkie, it thought that okay, this is the start of the new sentence, so it has broken it into welcome to, and then KGP Talkie starting with another sentence. All right, so this is not a proper the rule to put the start of the sentence tag. So what I'm going to show you here, let's say if I say welcome to and 3 dot, okay, and then KGP Talkie, and then again 3 dot. Let's go ahead and run this. So with this we see here by default it has splitted it into a 3 sentence, that is welcome to and 3 dot, and then KGP Talkie 3 dot, and thanks for watching. But let's say if you want to put your custom rule which says that divide it, let's say if you want to put here a star, then see what happens. So it has brought down this star, I mean this one in a single sentence, and let's say again if I put here a star, then so what happens here? Okay, so everything is in a sentence, a single sentence. Now let's say if I say this a period star and the period is start of a new sentence. All right, so it's kind of a sentence complete or a stop word, then how would you make sure that it should work? And to do that we need to write a custom strategy or a custom rule. And to write that custom rule, what we can do, we can just call create a new function def set rule. So this is the new function in which I'm going to pass a doc, and inside this doc I'm going to get all the token there. Then for token in, all right, so for token in doc, all right, so it says that -1. I'll tell you why I'm taking -1, because I'm going to compare it till this line, because once it once I compare this, I mean if I get this one, then I should say that okay, this thanks is a start of new sentence. All right, perfect. So here if I say a token, all right, so if token dot text is equal to which has period star and the period, then I should say that doc, then again the token dot I plus 1 dot is sent start is equal to true. All right, then we have here return doc. All right, so it says that here is invalid sentence. Let's say that should be if. Okay, so this is how we have written our custom rule. And what I'm going to do now I'm going to add it into a pipeline. You always need to add it in pipeline, otherwise it will not work there. Set rule, and then I'm going to set this rule before actual parsing. So here before, on which I'm going to set it before actual parser, I mean by default parser. And then I'm going to again create here a doc is equal to, I mean I need to create this one, okay, otherwise it will not work there, because here there is a new rule has been added, and with this it has parsed this document, okay, so that is why we need to rewrite it again. So let's go ahead and run this. All right, so with this what we get here, now what I'm going to do here, I'm going to again get the sentence. So for sent in doc1 dot sends, and then print sent. So in this you see here we have not got any particular the much changes, because this token has not worked properly. Let's say why and how for a token in doc print token dot text. So it says that here in the doc one, so you see it has broken this token in this instead of this. So what we need to do, instead of making it this much of the complicated this sentence, we need to first write a custom tokenization so that it should tokenize this in a single token, okay, these special set of characters in a single token. Only after that we can set a custom custom stop word for a sentence or sententizer. And to make sure it should run, what I'm going to do, I already have an example, so I'm going to copy so that I can show you here. Let's say I have this one, text welcome to KGP Talkie, then there are 3 dot thanks, and then 3 dot like and subscribe. Let's go ahead and run this. With this what we get, sorry, I should run this after this. Okay, so we have got this. Let's go ahead and see it. So it has here in the doc 1, welcome to KGP Talkie there. All right, so this is one sentence, and here it should actually show the another sentence. This is token there, and here rule, actually I have set it a wrong rule. I need to set this rule, I need to also correct that rule, but once you run this you will get an error. So what you need to do, you need to first remove that. Okay, so here NLP dot remove pipe. So which pipe you want to remove, that is set underscore rule. It says that, okay, it says that our label names are a tagger and the set rule. Let's see if we can remove this something like this. Perhaps it should have removed. Let's go ahead and now add this. Yes, it's working. All right. So now you see here with this parser what it has done. Now it has divided this in a single sentence, and this is into another sentence, and this is into a third sentence. Alright, so this is how you can add your custom rule while doing sentence analysis or sentence breaking. Now in the final stage of this lesson, let's go ahead and visualize the dependency and the entity using spaCy visualization tool. Okay, so in this we have from spaCy import displaCy, and inside we have doc is equal to, we have here a doc. I think we already have a doc, so we don't need to worry. We have doc here. Let's go ahead and display this by calling displaCy. So with the displaCy dot render inside this Jupyter notebook, we can just call doc, and then finally we can call style, and their style I'm gonna call a dependency style. Now you see here we have got here visualization tool, which says that welcome is a verb, to is ADP. Let me see, ADP watch. Yeah, so it was add position, and then we have a proper noun, and then again proper noun, and the noun, etc. Alright, so this is how you can visualize, and along with it's a dependency, how it is dependent to the another, like one prepositions, and for what we have used the conjunction like, subscribe. These are the conjunctions. Okay, I mean in between there is and, there is a conjunction, so like and the subscribe has been conjuncted by and. Okay, perfect. So this is the dependency. Okay, now let's go ahead and you can make this a compact as well, and to make it compact, what we can do, we can just call here the displaCy dot render, and then here we have a doc, then finally a style is equal to dependency. All right, and then here we have options. So inside the options we should pass some the dictionary, in which I'm gonna write here a compact, and compact is true. If compact is true, then it will be something like this. Okay, so it is kind of very compact. And along with that, if I set here a distance, let's say if I set a distance 100, then you will see the distance of these character words or tokens is 100 character. All right, this is how you can customize your display. Now I'm going to show you how you can visualize this named entity visualization. That I'm going to show you with this one. Okay, Apple isn't looking for 1 billion. Do we have somewhere? Yeah, here we have a doc here. Let's go ahead and copy that doc, and I'm gonna put that doc here. Let's go ahead and run this doc, and now I'm going to do here displaCy dot render, and inside that I'm going to pass here a doc, and then finally style is equal to ent. And now in this you see here Apple is organization, UK is geographical location, and $1 billion is money. So this is how you can visualize named entity recognition as well in a spaCy. All right, so this is all in this lesson. So there is so much things more to learn in a spaCy. I'll be covering few more things in the another lesson, like let me tell you, like similarity identification, entity linking, and text classification, and along with that how you can write your own custom rule, and how you can do a rule based matching. And then after that we will be doing a text classification and Twitter, Facebook, or LinkedIn post or WhatsApp status sentiment analysis. Alright, so there is a long way to go before we start our sentiment analysis lessons. Perhaps that will be 7th or 8th lecture in this lesson. But before that, we need to cover at least 3 to 4 more lectures to set a base for this video lecture, for this video lecture series. Alright, so thanks for watching. Please don't forget to like and subscribe so that you can get updates directly into your inbox. Bye bye. Have a nice day.